Hi there, my name is Paul Mallet. I'm a data specialist from the Skate Ontario section. Over the years working as a DS, especially in my role as a computer DS, one of the things that I've noticed is that a lot of the problems encountered while setting up a competition scoring system can be traced to the network that is serving to connect those computers. And in fact, over the years, the role of the data specialist has evolved to rely more and more on IT competencies, especially as they relate to computer networking. I'm happy to introduce this three-part video series that is aimed at both the new and experienced data specialists who are looking to improve their knowledge about computer networks and troubleshooting competencies as well. I'll be focusing primarily on Ethernet or wired-based networks, although a lot of the information that I'm going to be covered also applies to wireless Wi-Fi networks as well. I do hope that you find this information useful. In this module, we'll be talking about the computer network hardware needed to set up a competition scoring system. So more specifically, we'll be talking about modems, switches, routers, Ethernet cables, and network adapters. Let's start by comparing modems, switches, and routers. Knowing the difference between these devices can be challenging because they might look similar. That is, they might all look like boxes with Ethernet ports. To add to the confusion, in most homes, these devices are not standalone objects, but instead are often combined in different ways. For example, you might have a standalone modem that serves as an interface to the internet via a coax cable or telephone line in the case of a DSL modem, or perhaps even a fiber optic line. Connected to this modem, you might have another device, which is a router and a 4-port switch combined into a single device. And in most such home devices, they may also include a wireless interface to provide Wi-Fi access. Increasingly these days, your Internet Service Provider, or ISP, might only require a single device that includes an integrated modem, wireless router, and switch. But regardless of how your modem, router, or switch may or may not be combined, we can still understand the purpose of these individual functional units. So let's compare them. We've already talked about the function of a modem, which is to connect to the internet. A network switch connects devices within a network, often a local area network or LAN, and forwards data packets to and from those devices. Unlike a router, a switch only sends data to the single device it's intended for, which may be another switch, a router, or a user's computer, not to networks of multiple devices. Routers, on the other hand, select paths for data packets to cross networks and reach their destinations. Routers do this by connecting with different networks and forwarding data from network to network, including LANs or wide area networks, or WANs. In practice, what this means is that routers are necessary for an internet connection, while switches are only used for interconnecting devices. Homes and small offices need routers for internet access, but most do not need a network switch unless they require a large number of Ethernet ports. However, large offices, networks, data centers with dozens or hundreds of computers usually do require switches. And because a typical competition scoring system includes many devices that must be connected via Ethernet cables, they too require both a router and a switch. In simpler terms, a switch is used to connect network devices together. If you run out of ports for the number of devices you have, you add a switch. And if all the ports on that switch fill up, you can add another switch. There are two main categories of switches. Unmanaged switches have no configuration, interface, or options. They are simply plug and play, are less expensive, and they're often used in small office and home office environments. Managed switches have one or more methods, typically a web interface, that allows you to configure the operation of the switch. These are typically more expensive, more complex, and are used in larger business and enterprise systems. Switches can have a varying number of ports and network speeds. On the left is an example of an inexpensive entry-level consumer-grade unmanaged switch. On the right is another inexpensive unmanaged switch, but this one has 16 ports. Both of these switches support gigabit speeds, which means that they're capable of handling speeds up to a gigabit or 1000 megabits per second. This is plenty for a typical home and certainly sufficient for a competition scoring system. There are faster, more expensive switches and slower, less expensive switches, but these days, gigabit switches have become the standard for home networks. Coming back to the router now. A router brings a lot of the smart functions into a network. It works as a dispatcher, directing traffic and choosing the most efficient route for information in the form of data packets to travel across a network. A router can also connect networks together by routing data packets from one to the other. A router can not only route network traffic from one subnet to another, but it can also route data packets between the LAN and a WAN, such as the internet. And finally, a router can also run a DHCP server that assigns IP addresses to connected clients. Here are a couple examples of routers. Most home routers include a WAN port, and often one or more additional ports that effectively serve as a built-in switch. More often than not, this is a 4-port switch, and it's in fact rare to find more than 4 LAN ports on any home router. And more often than not these days, the router also includes a wireless interface to connect Wi-Fi clients. The router on the right is an example of such a wireless router. It has antennas for Wi-Fi clients, a WAN port that you would typically connect to your modem for internet access, and 4 LAN ports that can be used for your home LAN. On the left is an example of a wired router that doesn't include a wireless interface. It only includes RJ45 ports, which are used for Ethernet cables. To connect your router, switch, and network clients, such as laptops, you need Ethernet cables. There are many standards of Ethernet cables that have evolved over the years, but the construction of these cables have some things in common. One is that they consist of 8 color-coded wires, which are always twisted in 4 pairs. In Ethernet patch cables that are used to link network devices, these 4 pairs of wires are terminated using RJ45 connectors. Ethernet cables can be constructed in different ways, and it's important to use the correct type of cable for your application. The most commonly used cables are categorized as Cat5, Cat5e, Cat6, Cat6a, Cat7, and Cat8. By using the wrong type of cable, you may not achieve the optimal network speeds that your network devices are capable of, or you might be throwing away your money by buying expensive cables that offer no speed or reliability advantages given your network devices. So let's review the differences between these cables, but before we do that, let's talk about network speeds. I mentioned earlier that inexpensive switches and routers are available that can function at gigabit speeds. The speed of a network can be described by the amount of data that can be transferred per unit of time. Commonly, we describe these speeds in megabits per second, and most home Ethernet networks that use twisted pair cables operate at 10, 100, or 1000 megabits per second, although faster speeds are also achievable. To put this into perspective, older dial-up modems operated at maximum speeds of about 56 kilobits per second, or 56,000 bits per second. Early Ethernet networks operated up to 10 million bits per second. And most home networks now operate at 100 megabits per second to 1000 megabits per second, which is a gigabit per second. Faster network speeds are also achievable, but typically are not worth the expense for home networks. Aiming for 1 gigabit per second is both easily achievable and affordable in most home and small to medium-sized business networks. With a gigabit network connection, you can support over 100 simultaneous 1080p HD video streams or dozens of 4K video streams. The typical maximum length that can be used in a single run of Ethernet cable is 100 meters, and cables are therefore rated by the maximum network speed they can support over that 100-meter run. Cat5 cables support 10 or 100 megabits per second speeds at the maximum 100 meter length. Cat5e cables offer greater protection from interference and can therefore support a theoretical maximum of 1000 megabits per second, or a gigabit, at the maximum 100 meter length. Cat6 cables have no trouble supporting up to 1 gigabits per second speeds at the 100 meter length, and they can also support up to 10 gigabits per second speeds to a maximum length of about 55 meters. And by using stronger sheathing and foil wrapped around the cable conduit, or even foil wrapped around the individual twisted pairs, Cat6a, Cat7, and Cat8 cables can support even faster network speeds. But something to keep in mind is that Cat7 and 8 cables are thick, they're less flexible, and they can be quite expensive. And something else to keep in mind is that most computer-grade switches, routers, and laptops can only support up to 1 gigabit per second anyway. So the point at which there is no real gain relative to cost for network cabling is either at the Cat5e or the Cat6 point. And because the cost of Cat5e and Cat6 is nearly the same, the sweet spot for most home network applications is to use Cat6 Ethernet cabling, given its low cost and excellent performance with even long cable runs. So the last piece of network equipment needed in our network that I haven't yet discussed is the network adapter itself. Many laptops have an integrated Ethernet adapter, which can be identified by an external RJ45 port. Some laptops are slimmer than the height of an RJ45 connector, and therefore might either include an RJ45 Ethernet port with a flip-down lid, or may not include an Ethernet adapter at all. If your laptop doesn't have an Ethernet port, you can still connect it to a wired Ethernet network by adding an external network adapter, which can be connected to either your laptop's USB-A or USB-C port. Something to keep in mind is that most newer laptop Ethernet adapters support gigabit networks, but older laptops may only support much slower 100 base T networks. Although that older laptop will still work with your gigabit router and gigabit switch, any network traffic to and from that laptop will be limited to the maximum speed of the slower network adapter, in this case 100 megabits per second.